Hello everyone, welcome to today's joint webinar from Shiny 3D and QUICKSURFACE. I'm Tom from the Shiny 3D technical team. What you will see today, first I will perform a live 3D scan of this timing chain cover using our new iScan radio. Then Costa from QUICKSURFACE will take you through transforming this scan data to do the reverse engineering and highlighting the key features of their QUICKSURFACE for Solidworks plugin. Let's bridge physical objects to digital workflows together. Okay, so now first, let's take a deep dive in the iScan radio, the scanner itself. So, as you should know that this iScan radio is a trim-mode 3D laser scanner. So equipped with two dual light source, which is laser and infrared light. So you can see in the main interface, I just wrote down the control center. You can see we have a lot of functions available. So on the left side, we can connect to the Wi-Fi network, which can help us to log in our personal Shiny 3D account. And on the right side, you can see we have a storage. And we also can adjust the brightness in real time. On the bottom, we can quick do the calibration interface if we want to redo the calibration since you first receive this package. And then a very powerful showing function, which is wireless screencasting. So it's pretty convenient if you want to show some demos to your clients or the customers. And this is what we are doing right now. I'm screencasting from the iScan radio itself to intelligent TV. And we also have an independent PC software which we call the EXScan radio. As that software, we can do a lot of powerful functions like merge the multi projects and run the further post-processing work for some complex project and scan data. Yeah, hotspot, so you can using an independent hotspot device, and in case you are under a very complex Wi-Fi situation or environment. Okay, so now we move to the main scanning interface. You can see on the top side we have two main icons, the laser and the infrared light. So under the laser scanning, we have multiple adjustments to be done, and we need to adjust the brightness level before we do the official scan. And we can also switch the display mode. You can either select the data quality indicator or the texture display in real time. And by the way, in this brand new scanner, we support capture texture information under laser scanning. Okay. So on the right side, we have pay our attention to the parallel icon. So yeah, during the real-time scanning, we can switch the laser scan mode from cross line to parallel laser lines. And then we need to adjust the advanced settings like select the corresponding resolution for quick scanning, also whether we need the texture, and then most importantly, we need to select the alignment mode. Okay, so enough talking of this powerful device, so let's take a deep look at the real scanning performance. Okay. So for some objects like this, it's very thin cover, so we can scan both sides of this cover. And using our EXScan radio software, which on the PC's platform, to do the merging and align this to back side and front side together into one whole piece and meshing the data. Okay, so let's get started. Okay, adjust the corresponding brightness to a suitable level. A resolution for this case, I'll select 0.5 millimeter and no texture requirement, of course. Okay, so place the play button, then we can get our hands on the scanning officially. So as you can see, the scanning speed is pretty fast, and also the tracking is very smooth. So with the help of the markers, you can get the data very easily without any difficulties. So yeah, the blue area means the data is sufficient, while the yellow areas means the data is insufficient. So you can brush this area more times if you want to get a more completable data. Okay, so I think the front side is finished. So next we need to do some simple editings regarding this data. Okay, so we click the button and the device will optimize the data automatically. And then on the left side, we can continue the scan by clicking the play button on the top side. And then we can also do some simple editings by using the scissor icon. So yeah, we switch to the scissor icon and we need to rotate the data to a suitable angle. And select the selection type. Me personally prefer the lasso function. And drag this area. And click the garbage icon, okay? And rotate and check the front face side. And we can also using the connect domain function and reverse the selection so it can delete the unnecessary data in one click. So it's pretty quick and convenient. So once we have done the pre-editings of this raw data, we can click the complete button, confirm. Okay, so for now we can complete the first scan. And since we have just scanned the front side of this cover, so we need to flip it over to scan the back side. So for now, I just need to complete, and it will automatically saving the data and switch to another project too. You can see on the left side, and we just need to flip it over. And this time, I will also show you some new things. So first of all, the regular thing, we need to using the 30 laser line to scan the global data. And for some narrow space or some place we need to scan the fine details, we can switch to the parallel lines as we want. So you can see the switching is fully automatic. You can see the parallel lines showing up to scan some fine details on the object surface. And we can also switch it back. So in case we need to capture other global information. Okay, since the scanning speed is pretty fast, so it won't take much time to capture the whole information of the scan details. So same procedure as before. We just need to do some simple editings regarding the data itself. And in case we want to continue the scanning, we can also click this icon here to continue the previous scan. You can see we can always roll back in case you want to go back to the previous step. So that's why we provide a lot of flexible options for our customer. All right, and same we can using the scissor icon here to do the data editing. Okay. Connect domain function, which is very powerful. All right, so it's just take a few seconds to optimize the raw data to a good one. So it's pretty convenient as a pure standalone laser scanner. So it's very powerful. And we also noticed that there are some floating noises around the main data itself. So we can zoom in and do some specific selection of this area and click the delete button. So yeah, it's pretty convenient. And in case you didn't know, so we can also redo the whole editing part in case you accidentally delete some areas you do need to. Okay. Once you confirm, it cannot be reversed, just FYI. Alright, so we have done the 2 projects. So you can see inside the library, we can check the data. So yeah, we have 2 phases. You can see this is the front side and this is the inner side. So after we have done the scanning, we can move the data to our PCS platform software, which is EXScan Regio, and do the merging, and then output data in whole piece. Okay, so that's above all is a simple working flow of this cover scan. I hope you guys are satisfied with this simple demonstration. Alright, now we have entered the main interface of the EXScan Regio software. First thing first, we need to import the data from the device. Here we can see we have 2 projects. So what are we going to do before aligning them together is to generate point clouds. Here we go, and then we can click the alignment button on the right side to align these 2. This time we select the menu marker alignment and click and list 3 pairs of the common markers. The first pair, second, and then the third. Now click apply, and you can see the final result appear in the lower window, and we can click next. The data is perfect to me, and we can save this file into multiple formats like STL for further post-processing work. Now that we have looked at the scan data together, let's shift our focus to Costa for the reverse engineering process. Welcome!
Hello everyone, my name is Costa Franceliev and I'm the founder and the head of products of QUICKSURFACE. QUICKSURFACE is available as a standalone application, but also as an add-in for Solidworks desktop. This allows the user to import large scan data inside Solidworks, apply reverse engineering techniques and tools provided by QUICKSURFACE, and at the end be able to end with a native parametric model inside the Solidworks. The add-in allows the user to stay inside its favorite environment, Solidworks, and be able to apply tools both from the Solidworks as a technology, but at the same time use the reverse engineering tools that will help him to make efficient CAD models. Without any further ado, let's move to the technical presentation. This is the SolidWorks 2025, but our products are compatible from SolidWorks 2019 and higher. I will just create an empty document, and as you can see, QUICKSURFACE, if you install it, will appear just as an additional tab into the SolidWorks environment. This means that you don't need to learn how to navigate or how to create different features. It just you can jump into the direct workflow. How it works is by importing the scan data using our import button, and then this will allow you to just navigate and use this scan data inside the SolidWorks. Once I press OK, the scan data will appear inside the SolidWorks environment that you can navigate and reposition and align in using a lot of advanced features in order to be able to complete your project. The imported mesh appears just as a normal feature inside the SolidWorks, which means that you can hide and suspend and show and so on. QUICKSURFACE tab allows you to do the different tools that we'll go through, but also you can find a lot of useful online tutorials and as well with some example files. The reason we deliver these example files is that you can very quickly learn the software without any need for additional scan data. For example, this one will appear, and if you follow the videos, you'll be able to start your journey quite easily. With the help of the QUICKSURFACE, you'll be able to create really complex part, like this one on the screen, just by importing the scan data, and at the end you'll be able to end up with a model like this one. Furthermore, you'll be able also to create really complex assemblies, like this one, that allows you to have these shapes and be able to use them into the assemblies, like the one on the screen. Also, you can always just make compare, that will allow you to have a heat map and analyze the quality of your process. With the help with the QUICKSURFACE, you'll be able to create really complex shapes that otherwise are really difficult to create, such as this type of freeforms. Just hide the scan and show you the last model. And you can see that there are no limits for the reverse engineering process. In today's video, we'll be going through the basics on how to be able to import this specific scan that we created, and at the end how you'll be able to end up with this shape. The main idea of this webinar is to give you the basics and the general information how you need to do, but I must admit that you need to be patient and you need to have a engineering background in order to be able to create such a complex shapes here. I will just begin today with the empty document, and we'll import our scan data that we are going to go through. When you import, the file that comes is STL, which is a quite common file format, and it's unitless, so be careful when you import it to know how it has been scanned. In many cases, most of people use metrics, and it's saved, for example, in millimeters. Then I can just press OK. With QUICKSURFACE, we use our own rendering engine. This means that you can import a huge scan data. If there are questions how big scan data you can import, I would say around 100 medium triangles can easily be handled depending on your hardware configuration. When you get in here, you can do some pre-processing tools, so you'll be able to reconstruct, improve the mesh. For example, here, if I take a look, it's around 6 million triangles. But in many cases, this is really unnecessary because you need to have it much lighter mesh, not only for visualization purposes, but also for easy of use of the algorithms. For this reason, we have, for example, tools to reduce noise, scaling. You can flip the normals. For example, if the mesh is opposite, let me just put it back. And in this example, I would just go and reduce the size of the mesh with our decimate tools. What I mean with this is I can just put this to much lower numbers, for example 1 million, and then you can just press preview to see your results. This is a big mesh. It will take a while until you get the final results, but after that you'll be able to use the software in a much lighter way. As you can see, we achieved this mesh, which visually doesn't change at all. But the question is, we always need to think about the accuracy. How close the new mesh is? Did we lose any details? Although now we have only 1 million triangles, how accurate it is. For this reason, we have the analyzing tools that I can just click on it and see how much of the new decimated mesh is still within 10 microns. And you can see, even if I reduce down to 16%, I can just keep the accuracy of the shape. So I highly recommend that when you work, you take a look at the size of the mesh, as this is really important. The other things that you need to consider when you do reverse engineering is several fundamental steps. One of them is the mesh size we went through. The second step would be the alignment. And the third one is how you actually start reconstructing the shapes. The alignment is the process where you actually place the mesh into the correct orientation. What I mean with this is if I just go and take a look in the standard views, you see that this is tilted. How the alignment works is just by using several references in order to be able to place the mesh into the correct orientation. For this reason, QUICKSURFACE provides very easy to use tools for this. Let's take a look. What we have on the screen here is this planar area that will define my top plane, for example. This is probably my right plane, and then there is one axis that we can choose where we want the origin to be. Let's go and use our tools, which is called extract primitives. Extract primitives allows you to interactively pick the geometries from the scan data. There are several ways of making a selection. This means that if you just brush over, it will just select the shape, which in this case I don't need it. I'll just press deselect. And I'm going to use what is called the magic wand. This is a sensitive tool that will just pick the triangles based on the curvature, and in this case this is my plane, and I can just tell the software to create a plane for me. What I see on the screen is best plane fit. This means that the software created a plane that interpolates the shape in the best possible way. What you see on the screen is the color heat map that shows you how planar this surface is. Because this is a used part, it can never be perfect, so in this case I can just accept what it is available. Press create. We created this plane, and then the next step would be to pick the next reference. I will just repeat the same process by clicking on the side. We'll press fit primitive and check my deviation. As you can see, this is much better planar surface, so I can use it quite well for a reference. I will just create this one. For this example, I probably need an axis that goes through this cylinder, so I can orient it well. And it's actually a cone. I can just go and use again the selection. We'll click on it, we'll play with the slider in order to be able to get this shape, and then I will create a cone. This cone will interpolate in the best possible way. I can see the deviation. And then what we have here is to be able to constrain this to our different geometries. I can just click on this plane in order to tell the software that it needs to make a best fit of the cone, but at the same time keep it perpendicular to my reference plane. I can just press create, and as you can see, it created the axis for me as a reference. I completed my first steps here, so what I need to do is to align the object. Aligning the object works by picking the geometries that we created already and tell the software how to position the origin and the other reference planes. This feature is available into the align by reference command in the QUICKSURFACE toolbar. You can see how it's the current world coordinate system, and what we want to do is to define it differently so the object can be positioned there. I'll just pick this plane, which tells the software that this will be XY plane. And can I pick this axis? This will define where my origin will be. And then the third plane will define how it's rotated, and you can get this direction. Once I'm happy with this, I can just press OK, and the mesh will be aligned. The reference cannot be moved, so for this reason I will just hide them because I don't need them in this moment. But what happened let's check where is our origin at the moment. You see it's at the axis where our cone was. I can just take a look at the front plane. You see it's properly defined. My top plane is here and my right plane is correctly through the origin. What does it mean is that if I just place it into the standard views, this object is properly aligned and it's ready for reverse engineering. From here you can start even eyeballing and recreating the shapes, but QUICKSURFACE will help you by providing a lot more functionality for this. What we can do with QUICKSURFACE is the ability to create the cross sections. The cross sections are used for when you create your sketches to be able to create your shapes. Let's pick this front plane, and then you can see there is a cross section option here that allows you to create this slice through the mesh. If you go through the tutorials, you see in details that there are other options that you can pick much more accurate the information. But generally speaking, I can just create this cross section somewhere that I need to be able to start building my shapes such as extrusions, revolves, and so on and so on. Let's do our first very basic cross section, which is here. I can just press OK, and then the software created this cross section for me. What I need to do now is to start creating my first sketch. I can just use the front plane. Actually, I did it a little bit wrong. Let me just get back and do it in the right way. What I mean is, I can pick the front plane and create my cross section. What happens here is that you see this green slice on the actual mesh, and then it's projected on your working starting plane. But what I want now is just to create a reference exactly where my slice is, and there is an option which is called create on a slicing plane for this. I can just press OK, and now I can recreate my sketch in a normal way in Solidworks. What I have here is I visually see the scan data and I see the points where the section is, and this is exactly where I want to make my circle. I will just go to QUICKSURFACE and hide the scan because I don't need them. Again, as I said, it's a design intent. You can recreate this in a manual way, but what we want to do is to use our tools in QUICKSURFACE that will allow you to create much more accurate results. What we see here is the function which is called fit sketch entities. The way fit sketch entities works, you can just pick your geometry that you want to interpolate. For example, I can just brush over and it will create the best fit of arc for me. I can just undo. Or in this case, I just want to extract a circle. You have an options to create lines. You can fit a rectangle, slots, and hexagon. This will help you to optimize your process. In our case, I can just pick the area here that will be my circle, and then I can press OK. What you see now, we have this feature back in Solidworks, which is created as a normal Solidworks entity, and then you can use the standard tools. For example, you can just pick this and create a dimension. What you see, because mathematically QUICKSURFACE created the best fit, the radius here is something like this. But for manufacturing purposes, I don't think you really need such a detailed number. So in this case, I can just make it 18.60. So you see, you have the freedom to adjust your designs based on your expectations. It's not only based on the scan data. I can press OK, and what we have here is a normal feature. I can just press extrude so I can see what it is. Let's go back and show the scans. You can see that visually I can have the mesh as a reference, and I can do my reverse engineering with the help of the reference of the underlying mesh. Of course, in this case we have we need to add some draft, and the same draft on the other side, and you can see that this will make the shape exactly what we need to be. What else I would like to say is that during this process of reverse engineering, at any point you can just press compare. This will allow you to see how close you are with the underlying scan data. This is really important when you need to take a decision about the shape that you reconstruct, and then take an action. What I mean, I saw that this is not really accurate. I can just go and edit the feature, and I can change this to probably 1.5 degrees. That will make the shape much more accurate, and I can just press compare. You see that we get even closer to our results. You get the red here because the extruded parameters need to be adjusted on the other side. 1.5 degrees. Let me just hide the mesh so you can see what's going on, and I need to make this outward, and I can press OK. Showing the scan and press compare. You see that we achieve much more accurate results of what we want to get. Of course, SolidWorks has this interaction so that you can just move and adjust your shape where it needs to be. We also provide the tools which is called the instant compare. This means that once I am in the instant compare, I can just start dragging and see when it becomes green that this is actually within the tolerance that we specified for this shape. So what you see is that with the help of QUICKSURFACE, you'll be able to work in parallel with the tools of SolidWorks together with the tools of QUICKSURFACE, and you'll be able to end up with a fully parametric model. We have dedicated another session to go in details of the whole process of how you can bring the scan data inside, and starting from this mesh, how you can end up with a shape like the one on the screen. So I would like to invite you to stay tuned and visit our next session, where we will be going to show you the more advanced tools such as the freeform modeling, how you can create 3D sketch on the scan data, how you can fit sketch entities in more details, create a fit surface, and many more tools that QUICKSURFACE will provide. Also, if you join our next session, there will be promotion about the EX model that you can benefit from as a participant of this webinar. So looking forward to see you there. Now we'll just jump to the Q&A session.